I
Okay,
can
yeah,
see meeting recording progress.
yeah, I just started now. Okay, go ahead. Yeah.
Okay, so the last session we saw when the source is not going to send us files, how we are supposed to create a row set out of it and how we are passing that to our IAB. So in the next 2 days, we'll see how when the source is sending us files, how we will understand that file and how we'll create an output format. So I'll just give an overview of around 5 to 10 minutes. I'll just talk about how our different kinds of input files we have so far and how we are supposed to create the output. So now, as you are seeing in my screen, this is a flat file where this length is fixed. So it's a fixed length format. So for this particular bot, the input is my
Shaila,
file.
one thing, can you please go a little slow? I'm sorry, just little slow. You are too fast for me.
Okay, okay.
Okay, yeah. Hmm. Thank you.
Okay, so yeah. This is a example. What I am going to show is this is an example for a non-CDC bot where the source will be sending the input in a fixed length format. It is we call it as a flat file. So as you are seeing in my screen, this file they'll be sending it as, and my IIB will not be able to understand if I directly pass this file. So in this case, what we will be doing is we'll be creating a message set. In that message set, we will define, say, in my, according to the mapping document, this first set of fields will be referred to one field, and the next set of these 5 digits will be mapped to the other field. But my IIB will not be able to understand if I pass it directly. So initially, we will take this input in the form of block, and then we will create a message set. Message set is nothing but defining a schema and a set of field value, and you will just specify the length from, say, from 7 to 9, take 3 digits for this particular source field. So that is how we need to understand. So in this file, how we have is, this will not be the same for every bot. Only for this particular bot, we have a file header, and we also have a file trailer at the bottom. Okay, my system is very slow. Okay, we have a single file header and a single file trailer for this bot. In case if you don't have mapping for that, when you are getting a bot which has a file header and a file trailer, and if you don't have mapping, obviously you can remove that file header and trailer before you create a message set. Because if you don't have a mapping, there is no need of creating a message set and parsing that particular value. So if you are knowing that in earlier that if you are not going to have any mapping for your header and trailer, you can obviously go and remove that file header and trailer. That is, again, we are supposed to write ESQL code where we will remove that file header and trailer, and then we create a message set parsing the next set of fields. So that is how for this particular bot. Oh. Okay. So this is my file header, and the next one is my record header. This particular line, whatever you are seeing, is record header, and the other one is the detail. All these two detail. That detail may be like it is an unbounded. We cannot predict. This is not like a fixed length. So we will be creating in our message set this particular detail. For this detail, you will create one complex tag and you will make it as unbounded, which means how many ever input details you get it in your input file, it will be able to parse it and it will be able to send it to the output. The main thing which you want to keep in mind for this file input board is this is a fixed length file. And say if this particular field, when it comes from source, these fields are missing. And if you can see, the entire length will be mispositioned. But your IIB, you would have defined this first field will have a 5 length kind of length as 5, and the next one will have the length as 3. In case if the source is going to send messages like this, obviously we will get an exception because it will not be able to identify that this particular field was not coming from source, hence we are supposed to take. So in that case, we will not be able to do. So we are generating an exception for it. And also one more thing, what you need to notice is say in this particular input file, we are getting 1,000 orders. And if only this first order is having not of the length as we expected. So in that case, we are, it should be not the case that we are supposed to fail all the remaining orders. Only that particular order should be failed. So we can, we'll be throwing this particular order to an exception, and we are supposed to process all these orders. That we'll see in a separate session how we do that. So this is how like we want to understand. Even after you get the source system will be from different format. If it is going to come from a Windows system, the end of line will be CRLF, and if it is going to come from Unix, it will have LF. So that also we need to get it from the data mapper, so that will be that particular thing we need to put it in our message set so that it will be able to understand. So that was one example, and the output for that is something you will get like this. So this is a common thing in Albertsons, how we create a CMM. When we say the message is getting published to Kafka, when something IIB is processing and getting it published, this is how the common standard we are publishing. So initially the first parent tag will have the bot name. So this example I showed, the input file was for response customer order, and the output CMM is it looks like this. So if you see, this is the root tag for it, and within that you will see two tags, two child tags of this response customer order. One will be the document data, and the other is the response customer data. Every bot, say in case, take an example, if your bot name is going to be warehouse. So you will here have this parent tag as warehouse. Here you will have a document data section, and you will have a warehouse data section. So this is going to be common for all. This document data section, all these elements and attributes inside this document will be almost same for every bot. Only the things which will get changed is this response customer order data. Whatever bot it is, this data, because for some you will get this header and detail. In this file, we had header as well as detail, but in some other cases we will not have the header, so only this part will get changed. As I told you that we had two different multiple, these are the details in this file, these two. So for these two details, I will have two different detail in my CMM. So this is how the CMM output we generate in Albertsons account. And this is just an example where we don't have the record header and the record header and record detail. Only one thing you are having is your file header and your file trailer. All these are the detail. Don't worry, because I know the structure. I am telling you these are the header and detail. When it comes to your bot, when you see the mapping document, you'll be able to understand if your input file will have header, trailer and all. So that was one example, and this is the example where we will get XML as an input file. This today's session we'll be seeing this bot, like a one bot example where we will get XML as an input. You will get XML like this from the source, and we are supposed to take the values from it, and you need to map it. In this case, like under lines, if you see, there are two repeating elements line. So in this case, you will need to create a loop, and that will be mentioned in the mapping document. If you are getting any mapping, for say for line number, you are supposed to map to one particular target element. And if there is not mentioned anything like unbounded or the maximum occurrence for it, you can revert to the data mapper asking how we are supposed to do, because here from source we are getting two occurrence. So obviously in our target also we are supposed to loop. So this is how these are the things which you need to note it before you start with your development. This was one example of XML as an input file, and here it's a CSV file. So you can create a message set. Earlier if it is going to be a fixed length, you can specify the length of the fields, and since it is a comma separated value, you can mention it as delimited in your message set. And yeah, we have a delimited, you can get anything. So far we have got comma and pipe. So whatever the delimited file you get, accordingly we need to create a message set. So these are all the inputs we get. and the output is what I showed you, the output CMM. This is common for every bot. So this is a generic one which you can note it down, so that for every bot which you create, you can you will get an idea like how it needs to be created. Yeah, that's it. I'm done from my side. Yeah.
Shaila, one quick question. So you showed one file format, right, where you said if there is one field missing, right, then whole alignment of that particular record will change. Correct?
Yeah,
And
this is the one.
yeah, it's not showing up. Can you open up that once? Yeah, yeah, this one. So how we handle that in IIV while creating that particular message set for that particular record?
You were asking when in case of missing, or
In
you
case
are
of
asking?
missing. In case of missing.
In case of missing, we will the message set there itself. I will get a parser exception. Then again, we create a subflow where we need to split this file. We need to identify this record. For that, we should have any identifier in our input file. In the case which I am showing you, we don't have any string kind of thing coming from input. So I'll not be able to identify that. We need to capture in our VODD that this case we cannot, fail the order which is having the input data, and we can pass.
So we'll lose that record, right? In that case, correct?
Yeah, all the 1,000 records in this bot will be losing. Only for the interfaces which we are able to handle, which means anywhere if you say if you're getting a TOT somewhere here, that is going to be occurring in all the input file. In that case, you'll be able to fail only that particular record and process the remaining one. In this case, I cannot write the code because everything will be varying, the data will be varying. So that thing needs to be captured in BODD.
Okay, makes sense. Okay.
After this, Pratyasha will be taking. If you don't have any doubts, maybe I think she can start.
Sure.
Okay. Yeah, I'm stopping my. Pratyasha, you can go ahead, Pratyasha.
Okay. All right, Shaila, thank you. Let me just share my screen. Okay, so as Shaila has already told you, I am going to show you a particular non-CDC interface where we are getting the data not in the form of files, but rather in the form of an XML coming from the source. So the source is not coming from the database. As you saw in the case of the CDC BODs, where we were having a stored procedure, the stored procedure would process the message present, process the data present in the database, and then create an XML that would come on to NQ. Here the difference is that the source data that you're going to see on NQ is not coming from a database, but it is coming from the source, some other source in the form of an XML instead of coming in the form of a file. So this is a non-CDC interface only that we are going to see, but the difference is that the data is not coming in the form of a file, which is ideally the case of a non-CDC board, but rather it is coming in the form of an XML input. Let me just share my screen. I hope everybody can see my screen. So we have a board called Nutrition Product. So I'm going to show you how this board has been designed. Sorry, I opened the wrong one. So ideally, a non-CDC interface, that is a BOD or an interface where the data is not coming from the database, but it is coming from a source system, which is not a database. In that case, the file and the input node is usually a file input kind of node because the data comes in a flat file. But this is a unique kind of non-CDC BOD interface where the input is not going to be a file, but it's going to be an XML that will be posted onto a queue, which we get created with the help of the infra team. And we share that queue name with the source so that they can put their messages there. So this is the queue, input queue. Now this interface looks exactly like CDC, but the interior design, the internal coding is very different because our message is not coming from database. So we might even need to run a few queries inside the ESQL compute node where we are creating the canonical message. So you see there is an input MQ input node where the queue has been identified. This queue has been promoted to flow. So this is the name of the queue which we have shared with the source system. So the source system is going to put their message in the form of an XML on this queue. Then we have the audit input and audit output flows, which is, I hope you are clear with the usage of. And then we come to the compute node where we are creating the canonical message. So here we are forming the output message depending upon the data that we receive from the input message. So if I show you the code, it is a simple compute node code where the namespaces have been defined depending upon, again, the requirements that have been posed in the mapping document. There are few references that we have given. Sorry. So yeah, there are references of the input that I have given, that has been given here. This is the reference of the input message. This is the parent tag of the input message. I'll also show you the input message in a short while. And we have created a few references inside the input message depending upon how frequently we use them. When we have a more frequency of using a certain particular element, which is a sub-element to the parent, we generally create a reference to it, and that reference variable is put everywhere so that you don't have to write this entire, XPath again and again. So we have also started to build the encoding and version attributes. So this is going to reflect in the canonicals. Then we have implemented the logic as it has been outlined, or as it must have been shared by the data mapper, like what kind of canonical they wanted. So there is a document tag that is being created. The document tag, inside that the tags, whatever tags have to be mapped to whatever data that has been mapped. And later, we are also setting exception for any field that is considered mandatory from the target end. If they want that in the canonical, and if it is not there, we need to raise an exception. So we have made a function inside the code itself. Now this function helps us to raise an exception every time a particular mandatory field is not present. So this exception function or exception stored procedure sort of thing, and this is something analogous to a stored procedure where it is being called again and again. So the name of this function has been identified here, and the functioning of the entire working of the function has been defined at the end of the ESQL node. So you just need to understand that this particular function is helping us raise an exception whenever a mandatory field is not present. So the mandatory field has been posed by the data mapper. He or she already put that in the data mapping document, that whatever fields are considered to be mandatory from the target end, like if they are not present in the canonical, we would be raising an exception for them. So we are using this particular function here because it might have been identified by the target as a mandatory field. So if this data from the source is not coming and this target field is going to go as empty, then we need to raise an exception that the source is not provided as the data to map it into this field. So similar thing we have done for a few more fields down here. Again, this is something which has been already identified in the requirements. So depending upon that, the code has been made. Then there are some simple straightforward mappings. The source field and the target field to which it's to be mapped. This has been identified in the mapping document itself. So on the basis of reading the mapping document, we have put the mapping here in such a way that the target field is going to contain the source field which is supposed to contain. We have few more mappings here. There are few transformations which require casting also, where the source data is wanted in the form of a certain data type in which it is not coming from the source. So maybe the source data was coming in a separate format. So it has been casted into character because probably the target wanted it in a character data type. So that way this casting has been performed. Wherever it is not required, the data has been mapped without any transformation being applied. So it's called a direct mapping. So there are also loops implemented, and that loop implementation again is posed by the requirement. So if that requirement is present, that for a certain field you need to map all the attributes inside it in such a way that if a particular value is repeating again and again, then all the fields for it need to be mapped in a single canonical message. Then we use a while loop there so that a particular tag can be recursively created if more of the source fields are present for it, following a particular rule, which is again identified by the data mapper. So there are probably the requirement was here such that we needed two recursive fields. So that is why two while loops are present here. And the implementation of while loops is something that again, when you start coding, you can always come up to me or Shahila or Madhuri, and we can clear it out to you, because if we start showing every while loop to you, you will get confused. So it is better to, go to IBM's website, whose link we'll share with you, and you can go and check while loops there. Or even you can search it directly on Google and you will find the coding, like how this particular thing works. But I'm pretty sure you guys are well aware of the looping conditions in other tools and technologies. So it works in a similar way, only the syntax changes. So there are a few more mappings here. And once the mapping concludes, we are propagating the canonical to out, and then we are also generating the audit by putting the miscellaneous data value. So when we set this particular value, the canonical count, like how many canonicals generated for a single source message, and the number, the output audit is propagated to the out terminal also, once all the messages have been sent to output, which are generated corresponding to a single input message. And eventually, once all the messages have been transformed into a canonical and sent to the output, we are finally raising the exception for whatever fields were absent, or if any data was there which could not get transformed because it was of an incorrect data type from the source itself. So if there is any possible exception to be raised for that, those exceptions are all together raised by this particular block of code. So you can also see, I was talking about the set exception function, which was used earlier to raise exception in case the mandatory fields aren't present. So we have defined this procedure here at the end of the e-SQL so that it does not become a part of the code. It is just an independent entity which will be called whenever it is required. So here we are using this particular function. We have created this particular function so that we can raise exception whenever a user-generated exception can be generated whenever a source field is not present for a field that is supposed to be mandatory. So once that is done, this is how the canonical is getting generated. Now the catch here is that we did not require any mapping from the database, but there could be a chance where we are getting the data from a source which is not a database, but it requires a certain field from the database itself. So in that case, we need to run a few queries which would be run inside this e-SQL compute node itself. And we don't have a separate stored procedure here because it's a non-CDC interface. So we are running the queries inside the code itself. So another example where we are running a query inside the code because the data that is coming from the source is not sufficient to generate a canonical. We also need a few fields from the database. So we have another interface developed here. It's called store order, outbound orders. Please, Shaila, correct me if I'm wrong, because Shaila developed it. So I can give you a brief overview. If there is any specific question you want to ask, we can also include Shaila in this. So again, you see the diagram here is similar to what I just showed you. It again has an enqueue input node, and the message goes to Kafka. But the slight difference is when I say slight difference, I'm talking about the kind of design that we are implementing here and not the logic, because the logic changes with the business requirement. So when I say slight difference, the slight difference is in the form of architecture, which is that earlier, the interface that I showed you, we did not require any data from the database. Whatever data that was coming from the source was sufficient to create a target message, which would be consumed by the target system. But now we had this requirement from the target itself that whatever data is coming from the source is not alone sufficient. We also need some data from databases, and they tell us whatever database system they want to connect us to. So in that case, we have a copy of the database as an RDS database system, which has been explained to you earlier. So there we have the copy of all the fields or all the tables that are required from a certain database, and the data copy is also present there in the table. So that kind of database we can refer to whenever we need to put some data from database when the source data is not sufficient for us. This kind of process is known as enrichment. So some particular interfaces do not require the enrichment process like the one we saw earlier just now, and some interfaces do require enrichment. So one of the interfaces that required enrichment as per the requirements posed by the target is as follows. So this particular interface is also having a similar kind of code, except a difference that you will see is that we are having queries running here inside the code itself. The query running part for CDC interface is established and fulfilled by the stored procedure. But here, since we don't have a stored procedure, so we need to run those queries here only in the eSQL node. So let me search for a query which might be running inside here. This particular variable is going to contain the value coming from a database. So this particular query is going to run here, and whatever data comes from this particular query is going to be passed to an environment variable, which is being set here. This pass-through function, what it does is whatever data is coming from the database, it just without creating any transformation in it, it populates the value coming from the database query into this environment variable. So that's why we are using this pass-through function here. If you need to know further about the pass-through function, you can always go up and Google it. I mean, most functions that you see here in the eSQL code, you can always get them on the IBM website. You can just Google them up and you'll understand, you can get the entire understanding of what functions we are using inside the eSQL code. So, so this particular place is one of the places where we are running a query here. Now, this query is also something which is provided by the data mapper in the mapping document. And it contains all the fields that the target wanted and the source was not providing them, and these values were present in the database. So we ran a query inside the eSQL compute node itself. So wherever these values are getting populated, like there might have been a requirement that if that particular query did not yield the data, we would run this particular query, the other query. So these requirements again are posed by the data mapper only. So based upon that, we are implementing them here. The good thing for you people is whenever you have a certain kind of requirement, you can come up to me or Shaila or Madhuri, and we can, divert you towards a particular BOD which has had a similar kind of requirement, so that you can, go through the code which has been already developed, and then you can, understand the implementation of that particular requirement which has been posed onto you, and you can always, refer that already existing code to develop your new one. So that's a plus side of having this code being backed up somewhere. Whatever repository we've backed it up to, that's called dimensions, and we'll be discussing that later on. But we do have a place where all this code exists, whichever we are showing you here on the training sessions. So this is where this particular environment variable is getting the data from a database query. Now, once this has been set, you can see that this particular value is being set into various variables and various output fields also. It must have been done somewhere down the line. Let me see a particular line where it might be getting set. Okay, for instance, like this UPC country is getting the data from this particular field, this environment variable, and this particular environment variable was getting the data from the query itself. So the query data came into this particular environment variable, it got populated into this UPC country, and this is now getting populated by being concatenated with other values into this output field, which will be a field of the output target message that will be created once we move out of the compute node. So this is how we are also putting the data from database when the data is not sufficient when it is coming from the source. This process is called enrichment, and this enrichment process we are using, as far as we are aware so far, probably this enrichment process will not be used in most of the interfaces that we'll be developing. That is the, that is something which has been identified so far. But you must be aware of the enrichment process so that if in case we come across an interface in future where the enrichment is required, so you'll be understanding how it has to be done. This is all that I wanted to explain. If there is anybody who has any questions, they can ask.
Yeah, Pratasha. So I'm having one question. In the previous flow which you have showed for Nutri prod, there is one property in MQ that is this topic string.
Just a second. Okay. This topic string property you're talking about?
Yes, yes, correct. So I mean, where is this value is coming from, and what is the use of putting it here? I mean, why we are using this?
Okay. See, it's a field that basically contains the name of the topic, and it is a user-defined property. This field has been created here by the developer. I mean, it did not exist initially. So this particular field is getting its, what we're doing is that we are creating this field as an external variable, and it is also being referred to inside the code. You see this topic string. This is the same variable which has been created outside on the outside on the subflow. So this particular field, you can see that it must be getting populated somewhere. See, it is getting populated into the this particular output field. So this, when you put the value here in the subflow, let me see, let's go. Yeah, when you put a value here, this value is going to get reflected and populated inside this particular variable wherever it is being set. So when you declare it and you move ahead, so it does not have that the blank value which is being set here. That is just a value in case nothing else comes inside. Otherwise, whatever value you have set outside in the subflow, that value is going to get reflected here, and it will be populated in this output field called system environment code. So this is a user-defined property. It does not have a value. It's not a property which has been identified, been present here from the start, but it is a value which has been created by the developer itself. So this value is containing the value of the topic. Again, this topic value being mapped into your canonical was a requirement which must have been put by the data mapper. So that is why that value is being populated, and why it has been created as an external variable. The reason is because these fields tend to change with time. So when this value changes, you will not need to go inside the code and change it. You can just change it from outside. And if you put this value into your, you see this particular value of this thing has been promoted to flow. That is why it is now visible outside. So this topic string is present on the entire flow level, entire message flow level. So whenever this particular value, which is present here, it changes, say if in future somebody changes the name of the topic for some reason, or maybe some particular topic is getting completely used by some other interface, so we need to change the name of the topic. So in that case, what we can do is this particular value will be present in the properties file, because when you read the bar file, it will come as a property and not as a code value. It will not be visible there, because whatever you put inside the EC code, that is not visible in the bar file. When you read the bar file, you can see only the properties which are on the outside of the flows or the nodes. So these properties is going to be visible in the properties file. So you can simply go into the property file and you can change this value. And when you override that value onto your bar file, so you don't need to change the code entirely. You just need to change the property file and override your bar file with the property file. So that makes it very simple to change such, such properties which can change in time. So that is why this variable has been created here. But as such, it is not something, it's not a hard and fast rule that only topic string can be a kind of variable that you create. You can create any variable which you think can change with time or with the changing environment, or there might be a requirement that you will have to change the value of that particular property in future. For us, it was topic string. For you, it could be any other field.
Okay. Yeah. Thank you.
Anyone else? If there are no more questions, I think me and Shaila, Atul are done with our part of explaining things.
Okay. Yeah, I know today there was like a playback session planned, so that we didn't inform anyone on Friday. So that we
Yeah.
can do maybe in next 2 or 3 days, not a problem. Okay. So I'll talk to you guys offline how we can proceed on that. Okay. So yeah, for today, if anyone has any questions, we can talk about that. Otherwise, we can wrap up the call. Okay then. Yeah. Okay, let's meet tomorrow then. Thank you, everyone. Thanks a lot.
Thank you.
Thank you all.
Thank you. Thank you all.